Good morning, all. I'm Sunil Madhukar Gawade and currently working with an EPC offshore company, National Petroleum Construction Company Abu Dhabi. I thank you all for giving me an opportunity to express my views on the topic of our seminar, recent trends and issues in social science and science towards sustainable development. According to Gro Harlem Brundtland, sustainability is defined as meeting the needs of the present without compromising the ability of the future generations to meet theirs. It has three main pillars: economic, environment, and social. So the concept of social sustainability is not new. It has always been there. With each day passing by, it increasing its importance as the population is increasing, but the natural resources we have are limited. The global environment is changing very rapidly in recent centuries. At the same time, consumption of energy, water, and non-renewable resources is increasing. Therefore, study of human dimension of the causes and consequences of environment change and for more sustainable development path is essential. Basically, we have to do more with less. So from the last 6 to 7 months, we are having a very difficult time due to the COVID-19. So it has had a very bad impact on the society. As you have seen that many human lives have been lost. There is economic slowdown, stress among the people, and unemployment has risen. The global supply chain has been disrupted. The educational institutes are closed, and most of the classes are going online now, and there are healthcare issues and many more. So the coronavirus has impacted the society very drastically badly. So due to the pandemic, most of the people are working from home. Online education for the students have been started, and dependency of online shopping has increased as people want to avoid the crowds. They are relying on the e-commerce website to do their groceries, do their shoppings, and more preference for the digital payments have increased as people want to follow the social distancing norms and avoid directly incoming people in contact with the other people. So and rent for the transportation, people are using the transport transportation such as Ola, Uber. So the result is that due to the pandemic, as we have seen last 3 to 4 months, we have heard the pollution level in major cities had gone down, but it went down at the cost of the economic growth. As we have seen, there's total lockdown, transportation was stopped, all industries were closed. As a result, pollution came, levels were down. So now we move on to my area of interest, that is hydrographic surveying, and see how hydrographic survey with the help of scientific technology is helping us to achieve sustainable development. So offshore surveyors are involved throughout the exploration activities in well, and development phases of the oil and gas industry. This is a very high-tech part of the industry which uses very accurate satellite navigation system and advanced software. So there are two main segments of hydrographic surveying. First is the hydrographic surveying, in which we do bathymetric measurements, map the sea floor, measure the soil condition, that is the geotechnical part, the tides and waves, study the tides and waves. And second is the positioning services. So accurate position of equipment during the offshore construction and installation is very important while doing offshore operations. So any error in positioning can be extremely costly and have huge implication on and significant hazards. Also, there would be delay in the completion of the project. So it is very important to have high accurate positioning while doing offshore operations. So here are a few equipments which we use while doing hydrographic surveying. So, so most of the equipment use the sonar technology, that is sound detection and ranging for the operations. So we have here GPS is used for positioning, and this is the image of a multi-beam echo sounder, from which we get the mathematic measurement from the sea surface. Here we have a side scan sonar which gives you the seabed feature. This will map the sea floor, any depressions, any mounds, any trenches, any ridges can be clearly viewed with the help of this sonar. This is a sub-bottom profiler which penetrates the seabed surface up to few meters. It will give the subseabed geology, the strata, rock strata, how hard it is can be found out. This is a magnetometer. It will give the magnetic anomaly, any magnetic or ferrous object in your survey area. With the help, this equipment can detect it and give you an anomaly in your data. This is a single beam echo sounder. The function of the single beam echo sounder is same as the multi beam, giving the bathymetry. Only in multi beam echo sounder you will get a swath of the data, and here we will get a single data in a particular, single sounding in a particular location. Here are a few more few more equipments used. This is the ROV. So this is help us in mapping the ocean floor and doing the inspection surveys. Here we have a tide gauge, which is help to measure the tide. So we can measure the current in your survey area or the sea with the help of an ADCP, that is acoustic Doppler current profiler, and this is the sound velocity profile probe, which help us to measure the velocity of sound in the water. This is very important, as very important to get the correct measurement of bathymetry. We have to apply the velocity of sound in water. Apart from the velocity of sound, this will also measure the temperature and the conductivity in the seas. So here is a basic setup how we do mobilize a survey vessel. So all these equipments we have seen earlier are mobilized on a survey ship. So here we can see the side scan sonar is stored. It is stored with the help of a winch. A wire is connected, and it is kept above the seabed around 5 to 7 meters to get good quality data. Here is a sound velocity profiler lower to get the velocity of sound. We have the single beam echo sounder. You can see here it does not have a swath like the multi beam. The multi beam echo sounder gives the entire swath. We have the GPS antenna to receive the positioning service. So when the demobilization of the vessel is done, the vessel will proceed to the survey location, and we have a line planned and inputted in a software. So as per the line plan, the vessel will go to and fro and the sensors will collect the data. So this is the example of multi-beam data. This is how it looks. It will show the depth from the water surface, and the color coding shows the level of depth. Here we are an example of a side scan sonar data. See, it's showing gray in color, and here you can see the coarse and gravel transaction, and features can be seen here. This is an example of sub-bottom profiler where this is what seabed surface, and it's a water profiler sensor. We have the data for few meters below the seabed. Here we can see a reflector, one layer of strata, and so here are a few examples of hydrographic surveying. So it is used for safe navigation and construction support and installation support in the offshore. So before installing the wind farms, we need to do a survey. So inspecting services and positioning services are also provided by hydrographic survey. So navigation is very important. So once a survey is done, we produce a nautical chart. So this chart contains the bathymetry and the contour information. So these nautical charts are very important for the navigation in the seas. So the maritime commerce, where large ships carry import and export products from one country to other, use this nautical charts for their navigation. Also, an updated nautical chart will reduce the insurance cost as the risk is reduced. Commercial fishing uses nautical charts and other hydrographic products to locate fishing grounds and navigate safely. So here is one picture of offshore facilities. We can see pipelines, cables, and jackets. The pipelines are connected from one jacket to another. So in all the stages, like before the pre-engineering and during the laying of the pipeline, or after completion, the post construction, in all the stages we need to do a survey to know the accuracy of the installation. That is, and the positioning, which is very important, as in case of the installing the platform or a rig move operation, the position is very important. So before installation of the wind farms in offshore, a survey is required. So there is considerable amount of work is there to get the accurate bathy. To a geophysical, the sea floor mapping is done. Geotechnical, to know the soil characteristics, and in case there are any unexploded object, and UXO survey is required. And to lay the to do the cable lay or between the wind farms, we need to do the positioning. So all these operations require to require survey to be done during the installation. So as we all know, wind energy is renewable and sustainable energy. So we have to be ready, as we anticipate that the oil and gas and energy will be depleting and or gone in the future times. So the mission for the future is to supply enough sustainable energy for all. Another operation is the dredging, which is to remove sediments, debris from the bottom of the lakes, rivers and harbors and water bodies. So before the dredging, a pre-dredge survey is done to know the water level, how deep is the water, and after which the dredging activity is carried out, the debris are removed, and after the dredging operations we do a post-dredge survey. Again, we measure the water with the help of a multi-beam echo sounder, how much difference is there. So we take the data from the pre and post dredge survey and carry out a volumetric analysis using the software to know how much volume of debris have been removed. So It is important to maintain the baseline in the ports and harbors so that the vessels or ships coming in and out of the port comes to perform the operation safely and there are no hazards. So inspection surveys are done with the help of ROV. So ROV stands for remotely operated vehicle. So ROV is launched from a vessel. So it is connected to the vessel or the operator with the help of a bunch of cables which send electrical signals. So ROV contains a camera and and it and can take pictures and also record the videos while doing the survey of inspection. So see, you can see there it is over a pipeline. It is doing a pipeline inspection survey. It will record the entire pipeline with the position. So very this is helps us to get a clear picture of the object for which we are doing the survey. Also, such operations, ROV operations, are required for search and recovery operations. Also, we can see one arm of the ROV which can be helped to collect the sediment sample, and also if required water sample can be collected with the help of ROV. Next, we have the AUV. It is the autonomous underwater vehicle. So unlike the ROV, it is not connected to the vessel or the ship with the help of a cable. It is autonomous. Once the set of instructions are given to it before launching, such as the line plan and other information is loaded, the AUV will navigate to the hydrograph with a survey area, and with the sensors are already attached to it. So it will collect the data, seafloor, the mathematic information and other information, and it will come back to the sea surface. Once we recover the AUV, we will download the data and the data is available for processing. So for the AV with the AUV, we can map the seafloor, identify hazards to navigation, explore geologic formation, and also shipwrecks in our area of interest can be identified. This is a small boat, survey boat known as the remote survey vessel, the RSV, which is used to do survey in shallow waters as well as in offshore, where it is hazardous for the big vessel to go near the structures and other restricted areas. In the video you can see the RSV is deployed near the platform to do the survey and get the data. So it is very useful where the big vessels cannot approach due to safety concerns. This is another vessel is the USV. This is the recent technology which is used in the offshore survey field. So as the name suggests, it's an unmanned surface vehicle. So this operates without any human intervention. So this technology can help us in the current situation of pandemic as it reduces the human intervention. So the vessel, once given the preliminary instruction such as the line plan and other, will navigate to the survey area, do the survey by itself autonomously, and get the data back. Once it's recovered, we can download the data and do the processing on board or on the shore. So So in the current scenario, such kind of survey vessels are very important, so that less there's no current scenario of the current pandemic, very important, so the work is carried on without safely, without any issues. So we have seen how modern technologies of hydrographic survey are helping us to achieve sustainable development. So creating nautical charts for maritime navigation help us in many fields such as commercials, military operation, commercial fishing, transportation, underwater mineral resource development. So accurate positioning for offshore operations of oil and gas, and access to affordable, reliable, sustainable energy is essential for economic growth, employment, education, poverty reduction, and health and safety of all. So natural gas is a low emission fuel that can help to reduce the greenhouse gases while still increasing access to energy. We have seen how is a clean wind power is a clean source that we can rely for long term, and how survey is helping us to install wind power energy in the offshore. So it is affordable, clean and sustainable, that is without producing greenhouse gases or radioactive or toxic waste. So sustainable development. So in earlier we had seen during the pandemic how the pollution had gone down, but along with the pollution, the economic development index also went going down. That is not what we need. What we need is the pollution and carbon footprint goes down, but the social and economic development should go up. That is when we will call it sustainable development. So lastly, as per Edmund Burke, nobody made a greater mistake than he who did nothing because he could do only a little. So we all should do whatever little what we can do to achieve the sustainable development, so that our future generation will get access to the resources of clean energy and development. So I will conclude myself and once again thank the organizers of Sant Ramdas College of Arts, Commerce and Science for giving me the opportunity to express my views on the topic. Thank you.